So good evening, all of you. My name is Pramod Gaval. I am going to take live session 2 on a NPTEL course of mass transfer operation 2 week 2 assignment 2. I think all of you have gone through the week 2 lectures. In week 2 lectures covered mostly the design of the cooling tower and calculation of the cooling tower. So based on that, I am going to take a 8 question. It will be the simples. So I am going to first start from the first MCQ questions. Question was one is which of the following is an appropriate driving force in a air water direct contact cooling operation? Difference in. Can anybody tell the answer of these questions? Is appropriate? Yes. Okay. Okay. Right. All of it clear.
Yes, yes.
Okay. Question two is a blow down of the water from a cooling tower is done in order to means blow down means this side. This is the blow down of the cooling tower. The purpose of the blow down is to regulate the total dissolved solid, right? Are you getting?
Yes, yes.
Okay, okay.
Yes, sir.
Because here the SIBA BA is a no. There is a control the cooling water temperatures. No help down to the control the cooling water temperature, and also no uh, purpose to the prevent the growth of the algae. The solution of question two is A to regulate the total dissolved solid. Now question 3, if nearly saturated air at 45 degrees Celsius is contacted with water at 25 degrees Celsius in tower, which of the following will occur? All of you getting these questions? Understood. So which of the
Humidification of
following will
the
occur? Can anybody tell the answers?
A.
No. Means saturated air at 45 degrees Celsius contact with the 25 degrees Celsius. So here is a no humidification of air occur. Am I right? 1 minute. Okay.
Humidification of water.
No. You saturated air. Air at 45 degrees Celsius is contacted with means hot air. Hot air contacted with the 25 degrees Celsius water means cold water. If we hot air contacted with which process occur? Then
Outlet temperature is water temperature rise.
no, water temperature means 25 means it's like a cold temperature, cold water, right? Suppose so dehumidification of air this process occurred, right?
Yes, sir.
And also a rise in the outlet water temperature. This is the 40 degrees Celsius. They contact it with 25. So they this is the inlet. If you contact it to 45 degrees Celsius, so outlet temperature of water is increases. Am I right?
Yes, sir.
All of it clear?
Yes, sir. Yes, sir.
The evaporation loss of water no, because already cold water. The cooling of water no, already is a cold water. Now question for the most important function of the lowers. Lowers means generally these shapes like in cooling towers. Anybody know the function of this lowers in the cooling tower? Here is the options: to protest against the algal growth, to allow the airflow while preventing the water splash out, D, to enhance the structural strength of the walls, and D, all of these.
All of
No. Anybody?
B, right?
Yes. Sir. Anybody can try?
To allow air while preventing water pass
Yes,
out.
yes, right. To allow the airflow while preventing the water splash out. Is a solution of question. It's a view. Question 5. The most preferred material for the tower wheel. Tower wheels means this is a cooling tower. So here this is a wheel. So which material is for the tower wheels? Do you have any idea? Here is the option wood, concrete, PVC, chrome steel. PVC means polyvinyl chloride. Pardon it?
B. B.
B. No, no. This is generally preferred as a preferred material as a PVC, polyvinyl chloride. Question 6. The most preferred material for the casing walls of a cooling tower is. Casing wall means this is a fill materials. So here use like this. This is a casing. So which type of material preferred for the casing walls of the cooling towers? Anybody try? So you can answer this one. If you read the book, you know the answers. Yes. Anybody
FRP.
knew? 1 minute.
FRP.
Okay. FRP, right. FRP means fiber reinforced polyesters. Now this is a numerical one. Keep a calci with you to solve these numericals and follow to me. Question 7. Air at temperature 20 degrees Celsius and 750 mmHg has a relative humidity of 80%. What is its percentage humidity? The vapor pressure of water at 20 degrees Celsius is 17.5 mmHg. Here is a given Eg given 20 degrees Celsius. Then total pressure given 750 mmHg. Vapor pressure at 20 degrees Celsius given PAP 17.5. Have to calculate percentage humidity. Also given RH given 0.8%. Now calculate the percentage humidity. To calculate the percentage humidity, the formula is humidity at saturation into 100 degrees Celsius. All of you are following me.
Yes.
Yes. Now write down the formula of the
Yes, sir.
absolute humidity. P
Please mute. Please mute.
sorry, 1 minute. No, okay. It get cancelled. Okay. Now P by EAV. This is the relative humidity. EA is equal to EAV already given. Now 1 minute. by E plus EA 200. Now, sorry. Now already this is a RH. RH into now this term divided by vapor pressures means P E here is a not space. I try to solve it. RH into these terms means numerator and denominator divided by vapor pressures E by EAV minus 1 divided by EAV minus RH, right? Right, PA, sorry, PA divided by PS means RH into 100. Now put the value. Now put the value and tell the answers. Hello.
Yes, sir. Yes, sir.
Sir, how much? How much got the percentage humidity? All of you are given here. The total pressure given, vapor pressure given, also RH also given. Anybody got? This is the RH, relative humidity. This is the anyway got or not? Just we have to put the all the value here and calculate. It's a simple one, simple calculations. So I got the 79.61%. All of you got this value? Am I audible to all of you?
Yes, sir.
Okay, got this answer?
Yes, sir.
Sorry, 79. Wait, 79.61. Can I move forward?
Yes, sir.
Now question 8. Statement given: a sample of air has a dry bulb temperature Tg 32.5 degrees Celsius and humidity of 0.015 kg of water per kg of dry air. Total pressure given is 1 atmosphere, means atmospheric pressure. Means one, answer the following question. First is determine its the psychrometric property using by this psychrometric chart. First the adiabatic saturation temperature, wet bulb temperature and dew point temperature. Eg given 32.5, y given 0.015. Is this chart visible to all of you? So first calculate
Not
the
clearly.
okay. First calculate the TAS. So first locate this point TG 32.5 degrees Celsius and humidity 0.015. So this one humidity is 30, 1, 2, 3, 4 is 30.5 this one. Now go to first locate the point this one, right? Now follow the adiabatic saturation line to in parallel to the adiabatic saturation curve to reach the 100% humidity curve, right? Now draw the perpendicular to the x-axis is fine. Okay. So one away. So this temperature 26 26. All of you clear? Due to the image
Yes.
due to image I pasted here. That's why here is I cannot write 26 26 degrees Celsius. Now wet bulb temperatures. Uh, at the air and water systems, adiabatic saturation temperature is equal to the wet bulb temperatures. So equal for the only the air and water system, but not for the other system, other gas system, gas and liquid systems. So T wet bulb temperature is equal to same 26 degrees Celsius. Now calculate the dew point temperatures. Temperature TD. Now first same locate this point, same one TG and this 0.015. Now draw the line horizontally to the x-axis to reach the 100% humidity curve, and then draw the line perpendicular to the x-axis. So this temperature is 22.2 something, 22.2 degrees Celsius. All of you clear?
Yes. Yes, sir. Yes, sir.
Now the question 2. If the samples of air is heated to the 50 degrees Celsius, what will be the wet bulb temperatures? Means TW you have to find out. First locate the TG and now locate this point 50 degrees Celsius and this point. Now same to draw the line parallel to the adiabatic saturation to reach the 100% humidity layer. So this temperature is TW. This this is the adiabatic equal. This is sorry adiabatic saturation temperature. The same as a Whitwell temperatures. One is 29 degrees Celsius. Right, all of you clear?
Yes, sir.
Okay. 2, 3. How much heat is rejected if 1 kg of air dry basis is cooled down from 32.5 degrees Celsius to the 15 degrees Celsius? Here vapor pressure given of the water at 50 degrees Celsius 0.0168 bar. All of you try to solve these problems. You can also follow me. First, we have to check if some water vapor condense out when air is cooled from the 32.5 degrees Celsius to 15 degrees Celsius. So,
Noise is coming.
sorry.
Noise is coming from Takira, I think.
Okay. Now clear?
Yes, yes.
So in the Gmeet there is no option to noise reductions. So next time I try to noise.
Nice. Okay.
So first how to means calculate the saturation humidity. Here is a given vapor pressures of water at 15 degrees Celsius to calculate saturation humidity. Total atmospheric pressure 1 atmospheric is equal to 1.013 bar 0.0168 it got saturation saturation 0.0105. All of you follow to me. kg of water now condensation of water occurs equal to humidity given initially 0.015 minus saturation humidity 0.0105 equal to 0.045 kg of water divided by kg of dry air. Means condensation of water occurs from 32.5 degrees Celsius to 20 to reach the 15 degrees Celsius. Now to calculate the means how much it rejected. So to calculate the heat, the formula is enthalpy H equal to H humidity delta T delta Y this one.
The condensation of what there is 0.015 or
One
can you explain it? Yeah.
Yes. First we have to check. First we have to check if some of water vapor condense out when air is cooled from the 32.5 degrees Celsius to the 15 degrees Celsius. So initially at 32.5 degrees Celsius they have given humidity 0.015. At 15 degrees Celsius that get saturated. So here is a vapor pressure given. So we calculate the saturation humidity. So we can calculate here. Here is calculate the saturation humidity. So means how much condensation of water occurs by making a by making only the difference like initial 0.015 minus saturation humidity, it gets the value of condensation of water occurs. Are you getting?
Yes, in the above you have multiplied with 1802 divided by 28.97 or something. What is that?
These are okay. I think In previous section, yeah, I think you did not join. So 18.08 means molecular weight of the waters, and 28.97 is molecular weight of the air. This is a means 1 minute. Why?
Okay.
Yes, yes. This is a weight base. Sorry, weight basis. Are you getting?
Yes, yes, no.
Suppose if suppose if sorry. Suppose I remove this one. So the unit
This
of
is
this
kg by
only mole of water, mole of dry gas. Now to calculate the heat, this is the humidity. This is the formula for it calculate 0.05 plus 1.838. This is the formula into sorry 1 minute. Here I think okay sorry. Thus delta humidity means this one's 0.0045 into latent heat of water, latent heat of vaporization of waters at reference temperature. If you have a calculator, can you solve this? Put the value
12.7485.
12 point. No, so wait, what minute? Put the value 0.015. 12 point.
7485.
No, here I think mistake. Sorry. Change the sorry. Here is the reference temperature. Here is the reference temperature. T means 0 degree. Sorry. Now calculate. I'm also trying. Okay, right. 25. Yes, right. I got 13.15.
13.17.
Yes, sir. Kilojoule per kg of dry air means 13.17 kilojoule is rejected per 1 kg of dry air. All of you clear?
Yes, sir.
Now, same statement. Question 4 है, if the air sample is heated to the 50 degrees Celsius and its pressure doubles, what would be the its relative humidity and the dew points? Here vapor pressure of water at 50 degrees Celsius given, and this is the Antoine equation to calculate. I think maybe temperature we can calculate from these equations. So here Tg given 50 degrees Celsius and humidity given 0.015 kg of dry air. Now to calculate this, now here is the pressure is double. Initially P is given 1 atm, but here P is equal to 2 atm. So we have to calculate the relative humidity and dew points. So to calculate the relative humidity, we have to know the partial pressures, partial pressure of the water pressure. To calculate the partial pressure, use this. So put the sorry. So put the value of this one and try to calculate the partial pressure. I'll be solving solving this one. Here is a P given, Y given. So only calculate the partial pressures. After getting the solution, let me know. I am also calculating. Now the CH is the humidity. To calculate humidity, use this equation 1.005 plus 1.88 humidity 0.015 into 32.5 minus 0 plus delta by humidity is this one 0.0045 into latent heat of vaporization of water 13.17 kilojoules per year a year. Means 13.17 heat rejected kilojoule per 1 kg of the dry airs. All of you got this one. I'm moving to the if the air sample is heated to the 50 degrees Celsius, its a pressure doubles. What would be the its relative humidity and the dew points? So here given the vapor pressure of water at 50 degrees Celsius 0.122 and Android equation given. So initially given P is equal to 1 atm. So here we mention the pressure doubles and P is equal to 2 atm, right? Now to calculate the relative humidity, RH is equal to PA that represents into 100. Now we don't know the partial pressure. To calculate the partial pressures, I dash given 0.015 equal to it. All of you got these ones. Now here mention the total pressure is doubles. Means it means that the partial pressure also doubles. Use the Dalton's law. Total pressure is equal to partial pressure. This is the twice. We also have partial pressure also twice. Doubles. So it becomes double is 0.0 7 bar. Okay. 39.071. Right. Now to calculate the dew point temperatures. So generally, to calculate the dew point temperature, use the psychrometric chart. But we here cannot use because psychrometric chart prepared at at what at one ATM pressures. But here is a mention two ATM, so we cannot use. So to calculate the dew point, ED, use these Anton equations. At dew point point, partial pressure is equal to vapor pressures. So use this one 0.0477 bar. Now put the value and solve the dew point temperatures. So I got 30.5.24 Kelvin 32.04 degrees Celsius. All of you got this one? Now question 9 is based on the cooling tower. A cooling tower is to be designed to cool water from the 45 degrees Celsius to 30 degrees Celsius by counter current contact with air of variable temperature of 30 degrees Celsius, visible temperature of the 25 degrees Celsius and humidity 0.019 kg of water per kg of dry air. The water weight is 55 u 100 kg of water per kg per meter square per hour and air rate is 1.25 times the minimum. The overall mass transfer coefficient is given 2500 kg per meter cube per hour. The slope of operating line touching to the equilibrium line, slope of tangent 8.78, and heat capacity of the water given 4.187 kilojoule per kg per Kelvin. And the number of transfer unit given NTG equal to 6.14. Determine the dry air flow rate to be used and B the height of the packing and C the weight belt depression at the bottom of the towers. So some of the equation given to solve this solve these questions. If you have gone through the second week lecture on the cooling tower, so you all of you know this. I think all of you know this one, these equations. So first calculate the now Tg1 given Tw1 given Y1 given. Now use this equation to solve the dry air flow rate DS. DS PTL is equal to L CWL divided by now this is the operating line. Sorry, this is the equilibrium line. The tangent is given means if this is the initial point to touch this tangent, calculate the slope means h2 minus h1 divided by L1 sorry TL2 minus TL2. There is a slope. Other people getting this point. Slope is given 8.78 will give a into 4.187 now GS. Yes, 623 kg per hour meter square. Now here mentions the actual air rate is 1.25 times the minimum. One point two five into 623. Meter square per hour. Now this work is done. Now B. NTG given 6.14. Number of turns per unit. Then height of क्या? Height of turns per unit. Now we have to calculate height of turns per unit. Yes. Height of right. Now Z means the height of packing. 6.14 into 1.12 is 8 meter. Now see variable temperature at bottom of cooling tower. Now Tg1 given 30 degrees Celsius and Tw1 given 55 degrees Celsius. Calculate the variable temperatures, air temperature, variable temperature. To 5 degrees Celsius. 5 degrees Celsius is the variable depression at the bottom of the tower. I cover the all of questions. If you have any doubt, please ask me. Okay, if you don't have any doubts, can I close the session? Okay, thank you.